For what values of the non-negative integer n is the number 10 to the power of n plus 9 a perfect square? A perfect square. So n has to be a whole number, a positive whole number, and 10 to the power of n plus 9 has to be a perfect square. This is from the University of Melbourne School Maths Competition 2024. Is the final question in the intermediate division. So that's for year 9 and 10 students. Well, what could we do? We could start trying all the non-negative integers. If n is 0, we'll get 1 plus 9, which is 10. It's not a perfect square. If we try n is equal to 1, we get 19. Again, it's not a perfect square. 10 to the power of 2 plus 9 is 100 plus 9, still not a perfect square. What about the next one? 10 to the power of 3 plus 9. Not sure if you know whether that's a perfect square or not.
That is not a perfect square.
Let's look at the next one. 10 to the power of 4 plus 9. I know that is not a perfect square.
Yeah, that's not a perfect square.
Because 10,000 is a perfect square. 10,000 is 100 squared. And
see,
the
those are not perfect squares.
No, because the next perfect square after 100 squared is 101 squared. And definitely that's going to be bigger than 10,009. So it can't be a perfect square because there's no...
Yeah, it's not perfect square.
No, there's no perfect squares between 100 squared and 101 squared. So we both agree, we all agree, it's not a perfect square. To generalize, similarly, for any even n, we're going to get the same problem because 10 to the power of 2k is already... It is a perfect square.
Yeah, it is a perfect square.
It is. It's 10 to the power of k all squared. No matter what k is, okay? So saying n is even...
It's already about more than that.
Well, if n is 2k, it's an even number.
Yeah, it's already more than that.
It must be a perfect square.
It's already more than 2 minutes.
I see. And the next perfect square... The next perfect square is going to be 10 to the 2k plus 1. We can expand this out. We'll get 10 to the power of 2k plus 2 times 10 to the k plus 1.
Yeah, that is a perfect.
That is, but it's going to be too big. It's going to be bigger than 10 to the power of 2k plus 9. Okay, so long as k is like 1 or bigger.
Yeah, it's more than...
It's too big. It's definitely
it's
too
more than
big.
3 minutes now. Yes, I know that.
Alright, so 10 to the power of 2k plus 9 cannot be... Alright, now the tricky thing though is what happens if n is odd. If n is odd, like for example this one... Yes. This is not a perfect square.
Yeah, that's not a perfect square.
No, it's between 31 squared and 32 squared. 32 squared is 1024. That's 2 to the power of 10.
Yeah,
Did you know
you're
that's
right.
2 to the power of 10? What about 10 to the 5 plus 9? Or 10 to the 7 plus 9?
Yes.
How are we supposed to know if they're perfect squares or not?
Yes, I know that. That's not a perfect square.
Yeah, well, how do you know?
Because that's a bit too... This might be a bit too big to be a perfect square.
But some perfect squares are big. But these are not perfect squares. The proof is actually quite nice.
Yeah, that's actually... Those are not perfect square.
No. Here's the proof in the official solutions. I'll link to it in the description. What we can do is set up this equation, 10 to the n plus 9 equals x squared, where x has to be an integer. We can take away 9 on both sides and then factorize the right-hand side.
Yes, I'm just doing...
Yes, factorize into x minus 3 bracket x plus 3.
Yeah, you're alright.
And we can factorize the left-hand side. 10 is 2 times 5, so the left-hand side becomes 2 to the n times 5 to the n. Now, those factors could both be even. They could both be divisible by 2, but they can't both be divisible by 5 because they're exactly 6 apart. One is 6 more than the other, so only one of them can be a multiple of 5. This thing must be a multiple of 5 to the power of an n, which means all of those factors of 5, all of those factors of 5 must be within one of these factors. Actually, it must be the larger one. Because
It's more than 6 minutes.
we're getting there. 5 to the power of n is larger than 2 to the power of n. This larger factor must be at least 5 to the power of n, and the smaller factor can be at most 2 to the power of n.
Baba,
Yes.
you're talking a bit loud.
I thought you were talking a bit loud because you've got the headphones on.
You were talking a bit loud.
All right, and here comes the contradiction. Is that the difference of those, x plus 3 and x minus 3, must be exactly 6.
It would be 6.
It must be exactly 6, but 5 to the n minus 2 to the n is always going to be greater than 6 for n is 2 or larger. So just think and have no solutions, odd or even. There are no non-negative integers n such that 10 to the n plus 9 is a perfect square. It's a nice problem, isn't it?
Alright.
It's a nice problem about perfect squares.
Alright.
Alright. Say thank you and bye-bye.
Bye-bye.